everyone. So let's wait for a couple of more minutes. We can have a session in the morning. So we'll wait for another 5 minutes and then begin. Alright everyone, good morning again. So in today's class we're going to talk about Spring Framework. So finally we're going to see the component framework in action, and also if we have time we'll dive deep into aspect-oriented programming as well, but we will touch upon that theme and how sort of Spring Framework actually kind of helps us achieving aspect-oriented programming and makes your code really nice and modular without making forgetting. So we'll dive deep into these concepts. So first we will basically discuss the solutions that we just talked about in the last class, implementing this notification system using the dependency injection, and how that sort of that's an elegant design and tries to how it makes adding any functionality really clean, and so that's the exercise that we had for the last class, and some of you who have submitted, I've seen the exercise, so I think that those who submitted, that's really good. Those who have not, let me know in case you need any help in terms of implementing that. So we will touch upon the exercise. So the exercise is already available in the in its learning. You can try out it later on, and in case you face any difficulty, let me know. We want to understand any concept. So exercise is already available here, but it's implemented in Java. So, maybe those who, how many of you tried this at least? Did you try the exercise? Okay, 1, 2, 3, 4. So, those who have not tried, please try it and see if you kind of get the sense of why, how, what are the problem before the dependency injection implementation, and how dependency injection actually kind of cleans up your code. And then in today's class we will also implement that so in the last class we saw the dependency injection, like manual dependency injection. Now we will see how the containers and the frameworks actually help you do the dependency injection and make your code much more cleaner. So that's what we're gonna see. But that's, if you understand the basic problem that we are trying to solve with this example, seeing how without dependency injection, how the tight coupling is kind of problematic if you want to add new functionality and features, and then introducing dependency injection solves it to some extent, but we're going to talk about that doing a manual dependency injection is also not an optimal solution, and that's why we need a framework to help us do that in a much more clean and professional, in a more clean way. Okay, so yeah, this was the main idea behind implementing it with dependency injection. It benefits the refactoring. Those of you who have tried, what is your experience? I think one of the part of the assignment was also to reflect on, to see that you can appreciate the elegance of the dependency injection. So it tries to introduce the loose coupling in your code, and yeah, it makes the testing easier, and also for better extensibility. If you need to add a new notifier, so it's very easy. You don't need to test the rest of the code. All you need to do is call the main function, and then there you add a new notifier, and then everything works. So you can try out the exercise that I already have in the exercise solution, and let me know in case you need more help with that. We'll discuss that after the class. All right. With that background, let's start. So, those of you who have tried dependency injection manually, what is your experience? What are there any issues of doing the dependency injection manually? Yes. Any thoughts on this? Those of you who have tried dependency injection or the solution for the previous exercise, or do you not see any issue with that? Anything, or even if you have not tried the exercise, let's say, what do you think would be the issue with the dependency injection, doing the dependency injection manually, like the one that we did in the last exercise? What could be the issue? Anything that comes to your mind? Yes?
Doesn't seem very scalable.
Doesn't seem very scalable in what sense, like?
Let's say you have to make many instances, or you have to handle many objects, like creating a manual injection every single time doesn't seem very scalable.
Yeah, so scalability is an issue. If you have, imagine if you have a big, like large application, and then you need to remember where to add and what, like it's just a big mess, because you need to remember where to add and where to remove it, and so that's a really bottleneck on the scalability. Yes. What else? Yeah, maintenance. That leads to the maintenance overhead as well. What else are the issues that you see by doing the dependency injection manually? I hope you are all convinced that dependency injection helps. At least that part is everybody is convinced that it is needed. It's one more elegant way of doing writing code. But now we are debating about different ways of doing the dependency injection. One way, in the last class we saw the manual dependency injection, and one of the challenges is the tight coupling that it introduces, because you need to remember, and it's not a scalable solution. So that's a quite obvious like drawback of handling the dependency injection manually. Yeah, it's dependency management. It's a real mess. And one of the key aspects is also the component lifecycle management. So you need to. So if for example, if a component is obsolete, then you need to remove it from the container from your application manually, and if you don't remove it, it occupies the space into your application server, and that's also not a desirable solution. So the whole component lifecycle management is versioning of the component and redeploying a new component, that becomes really, really challenging with doing the manual dependency injection.
Just a quick question.
Yeah.
I might have missed it, but if I understood you correctly, like you were, let's say, pro dependency injection, and now what I'm reading is like manual dependency injection
So yes,
creates tight coupling.
yes. So let's take a step back. So this whole thing that the whole dependency injection was trying to solve the problem of loose coupling, right? So that the idea is that we write a loosely coupled code. For that we introduce the concept of dependency injection, and then there are different ways of doing dependency injection. Some ways of doing dependency injection are less tightly coupled, some are more tightly coupled. I mean, they solve the problem but to a different degree. That's the only difference. So here we are doing the dependency injection, but it's a manual dependency injection. You are making the object in the constructor and then passing that to the class that is supposed to use that, right?
So that would be like, for example, opposed to using maybe like Spring Framework or whatever.
So now this is a manual way of you are still creating the object and passing, right? Instead of creating the earlier what you were doing, we were creating direct object inside the functions that we or the classes where we were supposed to use that component, right? Now instead of that, what we are doing, we have removed that. Now we made the injection via constructor or the setter or getter method that we discussed in the last class. So and that is still a clean solution, but still not the optimal solution. And the reason being, you're still creating an object. Let me show you by example. I think that will make things much more clear. Where is it? I hope this should be. Oh, let me open this one. I hope it's visible in the back. So this is an example that we set out to do, and the problem is in the ID I can only zoom the text editor part and not the file name. So this is the main class where we are calling our notification service. So basically we have different notification provider, push notification, SMS notification, and then email notification. And we have a notification service that we are going to use to deliver the different kind of notification. So what we are doing is here, we are creating the notification service. So this is a different example of dependency injection. How? Let's say in the notification service, it depends on different types of notifier. Like this is an interface that it needs, and anyone who implements this interface is going to be like the framework is going to know it automatically. So this is the dependency injection, and the way we are doing the dependency injection is via constructor. So in the constructor, the constructor of notification service expects these dependencies from somewhere, right? So that's the main point. So instead of creating these objects here manually, you are now doing it via the constructor-based dependency injection. So meaning that this expects the dependencies to be injected into this from somewhere. And that's the main, and this is a method of doing it manually. Like so, the place where we are calling the notification service in the main class, we are manually creating the objects of the different notifiers that are. These are basically the implementation of these notification notifiers. The different notifiers that are. Let's say if you have a new notification type, right? Then you would create the notification for that, and then implement the notifier, and then add it manually here in the constructor. So this is a constructor of a notification service, right? So notification service constructor in which you are passing the notifier, a different notifier, and that is still a manual process. That's what I mean. So it's a dependency injection, yes. It's a constructor-based dependency injection. How this? Because you can see that this notification service depends on notifiers, and they are being passed to this service via the constructor of this. I hope that point is.
And that would still be considered more or less like tightly coupled.
Yes, so it's a relative degree. It's not like absolute. Like it's much more cleaner Then let's say for example creating those notifiers here, the creating direct objects of those. So instead of creating these objects directly here inside the notification service, it's much more elegant. Now you need to change, you need to make add a new notifier. All you need to do is just implement that code and just add it into the main class. So in that way you just only need to recompile and rerun only the main part of your application, the main part. Does that make sense? So it solves the tight coupling, but to a certain degree, and that's what we are debating. So okay, and this is a process of manual dependency injection. So this solves the. I hope this point is clear to others as well. Any other questions, thoughts before we jump into? Yes, no, no. Okay. So yeah, so the manual dependency injection helps, but we need something much more than that, and the reason being scale of the project, and manual dependency injection is not a right way to go about it. And of course, the lifecycle management is one of the most difficult tasks in the large enterprise level applications. So you need something that is much more handy. That's where the Spring framework comes into picture. So, what is the Spring framework? So the idea is in the last lecture we talked about enterprise Java B, EJB, that was sort of the standard for doing enterprise application in Java ecosystem. So that was the main sort of container provider, EJBs. But what happened was over a period of time, the developers of that were working on EJB, they realized that hey, these containers are really heavy weight, and for small, and the kind of customization the application needs is still not available in the EJB, and that's where the whole idea of this whole concept of Spring came about. From there, they were facing challenges with the EJB, and they tried to evolve that by making it much more modular. And the idea is that with this is that you can use whatever level of abstraction that you want to use. So in that way, Spring became a lighter version of Enterprise Java Bean by removing all the complications that were existing in the Enterprise Java Bean. So it is this framework in the Java world. It's really high on like for especially for building for enterprise level application. And approximately 60% of developers use Spring framework. So it's like really the acceptance of this framework, especially for the enterprise level applications, and the ecosystem around this is really strong. Yeah, and of course it offers the solution across spectrum of things that you would typically need in an enterprise level project. Maybe dependency injection, transaction management, and all the full stack sort of solutions that you would expect. And the main key advantage of this was it is lightweight. You are free to choose. It is modular. You are free to choose what level of help that you need from the framework. So basically, it contains the core part is the core container, which basically takes care of the beans. You remember beans? What are the beans that we talked about? So beans are basically your Java or component or Java classes that have their own life, and that they're floating in a container where the container manages their life cycle. So it's like all those Java beans are part of the Spring Core container, and then the context is also a concept in Spring framework where it's like it knows about the life cycle. It is life cycle aware for all the beans that exist in the application. It gives you much more flexibility to how you handle the beans basically in your and the expression language. So this is the way of how you build how the beans are created and how they are interacting with each other. So that comes with the expression language. We will dive into that in a bit. But then after the core container level, it also offers you support for aspect-oriented programming, and so that's also another concept which we will dive deep into. I don't want to introduce it before. And then on top you have data persistence layer where it helps you with the daily database transactions and persistence level. So all of that is available, and then also has like support for MVC if you are building a web application. So it has layer of support for depending on what you are building. And Spring has big ecosystem around Spring Boot, which we will also touch upon in a while. Also offers the security and everything. So it's a full-fledged application development framework. So let's dive a little bit into history. I just talked about. So EJB was really pain, and people who were working in the EJB, they became like kind of frustrated. They need something to overcome the challenges that they were facing with the enterprise Java Bean. So they started with basically the core concept of inversion of control and dependency injection. So that part actually was the initial thought of the where they wanted to sort of solve that problem, and from there on they added the aspect oriented support and all the stack that you see. They were afterthought, but it was designed in a way that it can you have the flexibility to use whatever you want to use. Yeah. So then initially all the configurations in the Spring ecosystem were XML based, and then they introduced sort of annotation based configurations, which we will also see. Just to know that this kind of setup was also existing in the legacy applications. And then Spring Boot was introduced to make like running these applications. Earlier, what you have to do is I think around 2009-10, you need to build the application, then compile, then deploy it in the separate server. The deployment servers and everything was separate. And now from around 2014, they introduced the whole ecosystem around it. You just build, and you have the embedded servers to run your application. So all of that part has been taken care of now in the Spring Boot. That gives you full-fledged flexibility of compiling, running, and everything in a simplified container. So setup and configuration was simplified with this. Now currently what we have is Spring 6.2 or something X. Now it is also improved since the last time I checked. So we are at the Spring 6, which has extensive enterprise level support. This is how it has evolved primarily to solve the initial thoughts were to solve the problem with the enterprise Java Bean that we talked about earlier. So key features, it gives you inversion of control container that we just talked about, that helps you do the dependency injections automatically and manages the life cycles of different components. Supports aspect-oriented programming, which is a way of cross-cutting concerns. How do you take care of the cross-cutting concerns in an application? We'll touch upon that if you don't for now we will spark this thought that it supports aspect-oriented programming. And then, of course, the data access and transaction management, all of that, typical things that you would expect from a framework. It does all of that, right? Of course, it has its own security, Spring security. It gives you enterprise level the security for application. So it has concept of called Spring security, that is full-fledged framework in itself that takes care of that. Yeah, so the main advantage here is it's a lightweight compared to the previous frameworks, and it really speeds up your development process, and you will start appreciating it once we dive deep into the how to start your application, how to start building your application in the Spring Boot. So it's a really speeds up your development process. So as I said earlier, you don't need to worry about the ecosystem for running your application. All of that has been taken care of by the Spring ecosystem now. As tools for testability, so testing is also really taken care with this. All sorts of testing, from unit testing to integration testing, all of that, for all the intermediate even testing, it provides the support system for that, right? And and also as you saw earlier, 60 or 70% of Spring Java applications are now centered around this framework. So it has a large community support and documentation as well. So this is in a nutshell. This is the pyramid of Spring framework architecture. The core container includes the core, bean, and context and implies. We will dive deep into all of them in a moment. So what is a Spring Container? Think of Spring Container as a placeholder which basically where all the beans resides. It takes care of how the beans are created, how the life cycle is managed, and then how the dependencies are injected. All of that happens, the magic that we talked about, right? It does that inversion of control and everything. That happens inside the container. So it takes care of all of these aspects: bean management, life cycle management, and then the aspect-oriented features that you need in the application. All of that magic happens inside the Spring container. So what is a Spring Bean? We talked about earlier what is Java Bean. And so the Java Bean is essentially a Spring Bean, which is a simple Java class with 3 more additional features. It has a null constructor, the no point, the what is it called? No argument constructor, serializable, and that's what would make it a Java class as a Java Bean. So yeah, so when you are creating a Java, when you are creating a bean, using the Spring framework, so it has all the life cycle hooks. So when the bean is created, when it is initialized, when it is destroyed, all of the, so whenever you are creating, let's say, an object of a class or a bean, so you have different kind of hooks, right? Pre-initialization, creation, and all of that gives you in a really handy way so that you can have full control on the bean life cycle. Yeah. So the way you create the beans in Spring is like, I hope the term bean is not confusing now. So it's basically a way of creating those Java classes that will float in this container, and they will interact with each other, and if they need dependency, container will take care of the dependency. So these are the sort of core components of the Spring framework. So the way you create bean is there are different ways and means in which you can create these beans. One is XML-based configuration, in which basically you have a configuration file in which you define, okay, these are my beans, this is how you should create them, and this is the kind of scope that you should assign to this. And then there is another way of creating these beans is like annotation-based, which is what the modern way of doing it. Nobody uses the XML-based configuration now, but this was the initial when this framework has started. Primarily the configurations were XML-based, and then now slowly they shifted to annotation-based bean creation. And yeah, so there are these 2 ways. You can do it via XML, or you could do it via annotations. So in this class, we will touch upon the XML base a bit, just to give you a flavor as how it was done. But then we will probably focus on annotation-based way of creating these Java beans. So basically, when you want to make something as a Java bean, all you need to do is define this as a component, and if you just add this annotation at the component, the framework wouldn't know that, hey, I am supposed to create this as a bean and keep in my container and manage its life cycle. That's one way of sort of creating the bean. And another way is using a bean in the configuration class. So you can also, at the method level, you can also create a new bean. So that's also another way in which you create the beans. And yeah. So this is much more nuanced way of creating beans, but this is typically most of the time that you will end up using it. You create an component in the on top of the class, and then the container would scan through. We look into how the container scans through, or and identifies which are the beans and which are I'm supposed to take care. But that's a natural way of declaring a Java class as a Spring Bean. This is much more nuanced way. If you need more control, you need to do pre-initialization, post-initialization, such kind of configuration. That's where you end up doing this the bean creation in this way. We will dive deep into all of them. So now just remember that there are different ways in beans in which you can create these beans, especially in the annotation base. If you need more control, you go by this creating the bean by configuration class, or if you need simply create the beans, then you just need to add the rate component and annotation to create those beans. And we talked about the XML based configuration. So this is one way, which is annotation based. This is another way. Like here we are saying, hey, this is typically a way of where you have a way of declaring your beans. So you say that, hey, I want to create my bean. So this is the bean ID that you give, because every bean has to have a unique ID, and then this is my class for which I want to create a bean. So this is basically telling the container that, hey, initialize this bean for me and create this bean for me. So that's the XML way of doing the same thing that we were doing here. This is old way. If you don't want to you don't have to do this, but just remember that maybe if you are working in some legacy applications, you might need to still deal with that. But primarily now with the Spring 5 above, all of the configurations are primarily annotation based, and that's what you would do here. So there are different types of beans. So when you're creating these beans, so you depending on the functionality that you expect from the bean, you can actually tell the framework to create your beans in different beans of different types. So you could create a singleton bean which has just single instance inside the entire container. So in the whole Spring container, you just have a single instance of the bean. So the way you do is say define the scope of the bean. So say, hey, create this. So typically this kind of things you would do with the, let's say, database initializations and connection tools. So where you need a single instance for the entire application. That's where you go and tell the container, hey, only keep the single instance of this bean for the entire application. Depending on, and then you have prototype beans. So every time you send a request, then you would create a bean. Could you think of an example where you would need, let's say, prototype bean as compared to singleton bean? What kind of scenarios that you would tell container, hey, I need this bean every time I ask for something? Only you have used it. You have used it in the framework that you are used to. Think of scenario where you would go with this. But you might not have noticed it, but I'm pretty sure you have used this in your web framework that you have used. This is something that you have encountered for sure. So this is a typical example. Let's say if you are making a REST request, and in that you are processing doing some business logic, and then returning something, right? So this is a typical example of where you would create a prototype beans for every single request. It needs to create a bean, needs to populate something, and then give it to you something, right? Return. So for every REST request, for example, what happens behind the scene in the MVC is like to handle your business logic, to return to you like some kind of objects that you are expecting from REST framework. Behind the scene, it creates the prototype kind of beans that for every request you need to create a new bean, and container will take care of creating the new bean, destroying it after it's no longer needed. Yeah, and the way you typically do is define the scope, saying, hey, it's a prototype type bean. So you have much more nuanced control on the container, because imagine you create these beans and then you forget about not deleting them or removing them from the memory. Then all of these beans newly created beans, they're floating in the container, and then in the end you are consuming like quite a lot of space inside your Spring container. So the way container would treat these different kind of beans, and once the objective is over, then it will throw them out. It's much more than the typical garbage collection that you have previously probably seen. So it's just not simple garbage collection, but it's an active life cycle management where the framework tracks these beans, and if they're no longer needed, it will throw them out of the memory. Yeah, so prototype beans is when you want to create something that you need it for every session, for example. Container, you tell the container that, hey, I need that, right? Yeah, so request, the REST controller, all of them, they work, beneath they have this kind of beans creation, session beans that you need it for every single session, all of them. Yeah, you need to create, you need to tell the framework, I need a session beans, and then it will create the beans that last only for the session. A typical application you will see, for example, we need to manage a session for a particular transaction. There you will need to create the beans and the session beans. All right. Yeah, so this is another example of XML-based configuration, where basically you will say, okay, you declare your own beans, and let's say if you have another configuration file where you have another sets of beans, you can also include that XML, and the framework will create the beans for you. So it's like, okay, I have created my own beans where I created my own XML where I define my own beans, but let's say if there are beans in another XML file, you will also include that XML file in the configuration file, and then you will create those beans also for you. Okay, now we know, okay, how do we create those beans? So container would somehow define these are my beans. So we learned about two different ways of doing beans. A, you define them in XML, define the scopes, what type of bean that you need. Other way is allocation based, where you need to specify that this particular component is a bean for the Spring container, and in that way you basically create the beans. Now the next question is, how do we use those beans? Like, how does okay, I have all my beans now, but I have my application as well. Then if I want to consume them, how do I go about it, right? So there are different means of accessing these beans in the Spring framework. So there are different means by which your application can ask for this container. So there is an XML-based configuration with class path configuration where you actually say, create this container, start this container, take these XML, take these like sort of bean that take this XML that I have specified my beans, spin up this container and give me this container so that I can start working. So you're telling the framework that, hey, these are my bean configuration. Now give me the context that I can start working with this, where all my dependencies, my beans are managed by your container. This is basically a way of starting this container in the Spring framework. So this is one way in which you will do. So it is class path XML application context. So this is one way in which you will ask the framework, hey, this is my application and I want to use your container, give me the context that I can start working, initialize. You basically initialize this container here. You can specify this single bean XML where you define all your beans. So this is an XML way of doing it. And then you will say, hey, I got this context, I got this container. Now what is inside this container? I want to have access to that, interact with that, and manipulate that. And that's where you will get the context and ask for specific bean that you created. So you will get all the classes of, not classes, let's talk about the beans. So all the beans that you created, you will have full control and full access to all of them, and you can even ask these beans by their names. You will, in the subsequent slides, you will see how to look inside this container, what is going on inside this container. But this is a basic way in which you will tell the framework, hey, initialize your container and give me all the beans that you created with the dependency managed. And then you start basically, your application layer starts from here. From here onwards, you will start manipulating or doing something that you want to do. I hope that point is clear. How do we create the beans? How do we start using the container? How do we initialize the container? There is much more nuanced way of once we start looking inside the bean life cycle, but this is basically an overview of how the beans are created, how you start using the container basically. Any question, comments before we jump into more details? I hope that this ecosystem, how it works. You'll be able to grasp much more once we look into the example. But I think somehow I can tell the theory before we jump into the examples. Any questions, comments, thoughts before we jump into the further concept? Yes.
This is not really like related to what you said. I'm just curious.
Mhm.
You were talking about like the Spring container, right? Is it like related in some way to Docker?
Yes and no. The concept are similar. Basically, container is where all the dependencies are managed. They're created. Life cycles. It is a life cycle aware. Yes, it's a kind of concept is more or less similar that you are familiar with the Docker, but it's much more nuanced. It's not simplified one-to-one equivalent that you can say it's similar, but the concept is similar. Basically, you have this bubble that takes care of managing things for you magically. Yeah. Any other thoughts? Oh yeah. So now let's talk about. So we talked about the container, right? It offers you different ways in which you can create these containers and ask for these containers. So there are different types of containers that you can have. So the first one is Bean Factory based container. See why it gives you so much flexibility, because again it depends on what kind of application you are building, what is the scale and scope of your application. Depending on that, it gives you flexibility to the way in which you can create these containers. Because if application is lightweight, then let's say heavyweight containers are of no use. So depending on what you are trying to achieve, you can decide which kind of container that you want for your application that manages the dependency of all the beans and stuff that you yes.
What does lightweight mean?
So lightweight meaning that you have like so for example, Spring has a concept of context. Spring has concept of core, meaning that if you have the core, let me show you. Spring. Sorry. See, so Spring offers you this context. Spring offers you the Spring core. So, for example, when you are using the context, it's a way of in an abstraction layer. So the way Spring works is beneath you have the core, and then keep on adding the layers on top of that. So if your application, all you need is just bean management. You don't need, let's say, aspect-oriented things into your application. You just need the Spring core. Then you will just simply use Spring core as a dependency, and then all you get is a Spring core container. You remember this diagram? So what you need from here, so you just need a core container, then you will only get that. You don't get the aspect-oriented features and the other stuff that you need on top of that. So in that way, you have flexibility of what you need. Like you can configure them. You don't get everything as a bundle together, and then you just need to have to use. So for example, so all the higher level of abstraction, they will have the lower. So for example, Spring core will come with Spring context as well. Spring MVC that you want to use, it will automatically include the Spring core for you. So core is the foundation on which all of this is built. Like the inversion of control, dependency injection, they are part of Spring core, and that is a must for even for the higher up, the Spring context and Spring MVC and all the other frameworks that are layered on top of this. So you can pick and choose. For example, you have an application where you just want to only need core functionality. You don't need Spring MVC. You are using some other MVC, right? For example. So it depends on what is the scope of your application. So you can configure different kinds of container. Ask Spring to create the containers in depending on your need. Where were we? So, first one is the Bean Factory. So for small applications, you just need the core part, and then you don't need, let's say, more complex stuff. Then you don't. Then you use Bean. Then you initialize basically your container with the Spring Bean Factory. Then you have application context, which is another type of another way of creating this container, this Spring core container, which gives you much more additional functionality that you would need. And yeah, and then they have different means and styles and how they each initialize the beans and like what kind of support they offer. So you have different nuanced way of these two different kinds of containers that you have. So for example, if you have the Spring Bean, which I was just talking about, it's a core, and then you don't need the, let's say, more web and advanced kind of support within that. Yes?
No, I was just wondering if you are using Spring, do you only use one container at a time?
Typically, your application will have one container, but it again depends on, let's say you have an MVC or you have a microservice. With each microservice has its own container, sort of.
So like typically one that you could have one container.
Yeah, typically in one sort of use case that you are like application that you're dealing with, have one application context in which you are dealing with. But of course, within single application, you could have different sub applications or the microservices that and then there you will have, they each will have their own container. Yeah, so depending on what features that your application need, you could choose whether you want to initialize this, whether you want to get this container as a Bean Factory based container or application context. We'll look into both of them once we look into the example, but just for the theoretical part, just understand that hey, there are different ways in which you can ask for these containers, and they will do different kind of things for you depending on what you need. So you could, for example, if you need web support, then you typically go with the application context. Yeah. So configuration support and all, based on the feature sets that your application expects, and that's why I said this is for lightweight applications. And typically in enterprise level application, you end up using the application context because this is much more powerful and has a lot of other features as well. Yeah, so let's quickly dive into these different containers, how do you create them, and then we will see example of each of them and dive deep into the how they actually help you doing the dependency injection in action. So, but first theoretically, because it's a chicken and egg problem. If I throw the examples at you without explaining these concepts, it will be difficult to get your heads around. But once you understand this concept theoretically, then you will appreciate the code much more easily. So now, do we need a break? How much is? Should we take a break? Okay, let's take 5 minutes break and then we jump into this. This is quite a long topic.